Okay, 1.6, representing functions as rules and tables. We're going to look at the vocabulary. A function consists of a set called the domain, containing numbers called inputs, and a set called the range, containing numbers called outputs. A pairing of inputs and outputs such that each input is paired with exactly one output is a function. A function can be represented using a rule that relates one variable to another. The input variable is called the independent variable, and the output is called the dependent variable. So I might do this if I were you on my paper. Okay, when I talk about inputs, I'm talking about x's. Those are inputs. It's also the domain. And I know that the input variable is independent. So I might kind of make a list. I'm talking about the x, the input, the domain, the independent, whenever I say one of those. When I'm talking about the y value, I'm talking about the output, the range, and it is dependent. When I'm talking about the y, the output, the range, it is dependent. So I'm going to use those words interchangeably. All right, let's go ahead and look at example 1. You have a much better looking table than I do, luckily. Someday my computer will work like I need it to. Come on. Okay, so you have a much better table than I do up here. But we can see that the input table shows the cost of various amounts of regular unleaded gas from the same pump. We're going to identify the domain and range. So I'm going to say D for domain. And remember, the domains are all the inputs, all the x values. So we've got 10, 12, 13, and 17. The range, those are the outputs. We've got 19.99. We've got 23.99. We've got 25.99. And finally, we've got 33.98. So we've listed all the domains and all the ranges. When you're finished copying this down, go ahead and flip it over. Okay, remember, a function is really important because each input is paired with exactly one output. So we're looking at these pictures for example 2. We've got 2 pictures. We've got this one, and here's my inputs. Let's label it inputs. We've got 0, 5, and 10. Here's my other circle. This is my output. I've got 2, 3, 4, and 5. Now 0 goes to both 2 and 3. 5 goes to 4, and 10 goes to 5. Let's read over that definition of a function again. It says that each input is paired with exactly one output. Is any of these inputs paired with more than one output? Which one? 0. So this set of numbers is not a function. Okay, and then we've got a lovely table. we've got our inputs and our outputs. We've got 0, 1, 4, and 6. And we've got 0, 2, 8, and 12. So let's look at our inputs. Are any of those numbers repeated? No. And none of them go to two numbers. So this would be a?
What does that mean by none go to numbers?
Okay, so 0 just goes to 0. There's no extra number in there. 1 just goes to 2. 4 just goes to 8, and 6 just goes to 12. None of those are repeated, none of them have two numbers next to them, right?
Oh,
So this is a function. I'm going to give you an example of one that's not on your paper, because this one gets tricky. Okay, let's say I have this. Here's my inputs. Here's my outputs. Now this is tricky. Is this a function?
Yes. Yes, we did.
no.
Why is it? They all go to 0, but what's most important is there any of these numbers in the input that have more than one arrow leaving it?
No.
1 has 1, 2 only has 1, 3 only has 1, and 4 only has 1. So it is a function. What does that tell you? That tells you that you've got to look in the input section and see that they only go to one place. We're not ever looking at the output. It doesn't matter how many places the output goes. What matters is how many places the input goes. So you look in the input and make sure there's only one arrow from each number. So do you guys see the difference
Yeah.
between the blue and the black?
Yeah.
If we look at the blue, the input has two numbers coming from it, two arrows. But the black one, all the inputs only have one arrow. Does that make sense?
Yeah.
Okay. That's really important and it's kind of tricky. All right, let's look at example 3. We've got the domain of the function y equals 2x is 0, 2, 5, 7, and 8. We got to make a table for this and identify the function. So the first thing we do is make a table. We label over here, we've got the inputs and we've got the outputs. And then my inputs are 0, 2, 5, 7, and 8. How did I know those were the inputs? What word up there made me think those were inputs? Domain. Domain is the same as inputs. Okay, now I've got the function y equals 2x. How do I find out what the output is? Yes? Yep. Inputs are x, outputs are y. So I'm going to take those x values, those inputs, that domain,
You said what?
and plug it in. I'm going to explain. 0, that's my x,
You said to multiply what
right here.
by 2x by
0, it goes in for x. So it becomes 2 times 0. That gives us 0. And then we're going to do 2 times 2, which is,
1.
and then what do? Is 10. And 2 times 7 is 14. And 2 times 8 is 16. Okay. All right, now the fun part. We've got a table and we've got to figure out what the function is, what the rule is. Okay, do you guys see the table on your paper? You've got this,
Not a function.
in, out. You've got 0, 1, 4, 6, and 10. And they go to 2, 3, 6, 8, and 12. Okay. Remember, these are the x values and this is the y value. What would I do to the inputs to get this as an output? Yes? Add 2. Let's see if that works. 0 plus 2 is? 1 plus 2 is? 2 plus 4 is? 6 plus 2 is? 10 plus 2 is? 12. So my rule is all of my outputs are my input, which is x, plus 2.
Whatever the first number of the output you multiply, divide, or add to
Yes.
for the other one.
And you got to make sure it works for the other ones.
So how are you gonna know how to multiply, divide, or add?
Okay, so if instead my table, let's say my table started out 1 and went to 5, and then 2 it was 10, and then 3 it was 15. So I'm like, okay, what do I do to 1 to get 5? Multiply by 5, right?
Yeah.
So 5 times 2 is 10, and 5 times 3 is 15. So I know that my function here is y equals 5x. You guys, make sure you ask, like Daniel's asking, if you need another example or don't get what I'm talking about. Okay. I'm really working on the reading the minds thing, but I'm not quite there. That was a joke.